Redis Enterprise is the database for the instant experience that powers any data model, any deployment option, and a multitude of use cases. See why more than 7,100 customers worldwide, including Microsoft, Staples, and Twitch, choose Redis Enterprise for their database needs. Visit redislabs.com/InfoQ.
When we talk about observability, we typically talk about the three pillars of observability: logs, metrics, and tracing. While logs and metrics could be better, most teams seem to have a good handle on them. There's still a certain amount of voodoo around tracing, or at least tracing done right.
Today on the podcast, we're talking to Yuri Shkuro,
who's the creator of Jaeger. Yuri is a software engineer at Uber NYC, author of the book Mastering Distributed Tracing, and as I mentioned, the creator of Jaeger. Hello, my name is Wes Rice. I'm the co-host of the InfoQ podcast. On the InfoQ podcast, we chat with thought leaders in software on a weekly basis. Today on the podcast, we're discussing tracing, specifically the OpenTracing API, Jaeger, and tips and advice from Jaeger's creator. Yuri, welcome to InfoQ podcast.
Thank you for having me. Glad to be there.
So let's talk about OpenTracing. What is OpenTracing?
OpenTracing was created as a standard API for people to instrument their code. So it was focused on a very specific problem of observability, of how do you get tracing data out of an application. Right? It doesn't deal with what you do with that data. It's just how you describe what happens in your application with a certain data structure and certain API. It's very similar to login API, except for tracing.
And then so Jaeger is an implementation of it?
Correct. Jaeger is a tracing backend, first and foremost, but it also has a collection of libraries which implement OpenTracing API so that if you instrument your application or your framework with OpenTracing, you can plug in Jaeger Tracer and the data will start flowing to Jaeger.
So Jaeger's at Uber, right? Jaeger came from Uber originally, right?
Correct.
Does Uber use the upstream of Jaeger, or is it a different implementation?
We build our own internal binaries, but we import the upstream as sort of as a library, and then we add certain infrastructure components to integrate better with the Uber infra, and then we run those binaries. So it's like mostly upstream Jaeger, but with some.
And then is Jaeger part of the CNCF?
Yes, it's an incubating project on CNCF.
Nice. How long has it been incubating?
We joined in September 17th. So it's 2 years. We're planning to graduate hopefully this year.
I saw that you're also a member of the W3C Distributed Tracing Working Group, an invited expert. What's that group like?
So that group is a group of representatives from different vendors, and its goal is different from both Jaeger and both OpenTracing, is that it tries to establish certain data formats that various tracing systems can interoperate with. So the most important format is how to encode trace context in the wire in the request, so that if you have, let's say, an application instrumented with Jaeger and you make a call to Google's big table or something, how do you make sure that Google can understand what Jaeger trace context looks like and pick it up and continue to trace? And so that's the interoperability between different tracing systems.
So a few months back, March, I want to say, sometime around there, OpenTracing and OpenTelemetry announced those two projects were merging. What does that mean for Jaeger?
So what it means is, first of all, OpenTracing, as I said, is a different domain space from Jaeger itself, right? And so OpenTelemetry, we think of it as the next version of OpenTracing and OpenCensus, like these projects merged. And so it still solves that same problem space as how do you instrument your code and get the data out. That's all it cares about. It doesn't care what you do with the data. And so that's what Jaeger cares. Therefore, these two projects are still completely complementary, is that you can use OpenTelemetry to instrument your software. And then once you start exporting data, you can point it to Jaeger, and Jaeger will start receiving it and processing and do data mining, visualizations, everything that we do. It includes also metrics. OpenTracing was purely tracing. OpenTelemetry also includes the metrics API, so you can export your metrics to Prometheus or some other metric system.
A lot of times when people are looking at tracing, it's Jaeger and it's Zipkin that I hear about. How does Jaeger compare to, say, Zipkin?
Very similar. If you read my old blog post on Uber Engineering blog about how Jaeger came to be, we actually started with a system which was half custom, half Zipkin, with like Zipkin UI specifically. But then we eventually evolved into a completely independent system. And so feature-wise, they're still pretty close. I think Jaeger has a bunch of new features that Zipkin never implemented. For example, we internally run so-called adaptive sampling that our backend continues to calculate what sampling rates we should be using in the client libraries. We also have done a lot more advanced visualization tools in our UI. But again, on the very high level, they're fairly similar projects nonetheless.
I'm curious, why not build on Zipkin? Why implement another tracing library?
There's two reasons. One reason is Uber, when I joined and when there is no Jaeger yet, there is already some custom implementation of tracing which happened before Zipkin event. And so we had to maintain that. And so we had to build a custom collection pipeline for that data format anyway, right? And which what we started with. The week after we deployed Jaeger, we already had a whole bunch of services reporting data in that other format. And so we didn't have visualization. That's why we used Zipkin UI for that. But our internal collection and storage was always sort of built from scratch. And eventually, approximately at the same time, we started OpenTracing as a kind of a standard API to collect data in the application. So we built client libraries in Jaeger as well. And Zipkin was originally participating in OpenTracing actively, but then they sort of off a bit. And so they continued with their own custom instrumentation, which is Brave and some other client libraries that they have, which are not necessarily OpenTracing compatible. So you can't swap for another tracer. And I didn't want that for Jaeger. We always wanted to be based on a standard so that if people instrument with certain API, if they want to switch from Jaeger to another thing, or even Uber internally, if we instrument a whole bunch of applications and then we said, you know what, Jaeger backend isn't working out, let's switch to some commercial vendor. We wanted that flexibility. And Zipkin didn't really have that because it was always focused on its own proprietary, almost proprietary API, even though it's open source, but it's like you kind of locked into that API. And so that also moved us towards changing our backend to be more representative of the OpenTracing data models, which again, they were slightly different from Zipkin. For example, the logs that you record in the spans, the structured logs, Zipkin didn't really support that. And so we built our own backend which did support that. So eventually we kind of came to a conclusion that there was no point for us in maintaining like compatibility with Zipkin. We're still compatible with it in terms of data. So you can actually run your Zipkin instrumentation and send all the data to Jaeger. Many tracing platforms do that because Zipkin is still very popular in many places.
When we talk about observability, we talk about logging, we talk about metrics, we talk about tracing. At different levels of scale, what thoughts, what advice do you have on what you should log, what you should develop metrics for, and how you should trace?
Scale is an interesting question, right? So you can think of scale as just the throughput of your overall system, but you can also think of scale as the complexity of the system. And so you could have a monolith application which has a huge scale in terms of throughput. Like Facebook front end, like the web front end for Facebook is actually a monolith today, still, right? Because obviously it has a massive throughput. And when you're working with that kind of software where scale is on the throughput but not on the complexity, you can probably get away with metrics and logging as the observability tools. But as soon as you get into more microservice-oriented architecture where there's a lot of components, like in case of Uber, if you pick a request a ride, that request that goes to the backend touches probably from 30 to 50 services depending on your features and region where you are, right? So there's a huge communication network to actually serve one single request. And so at that stage, not having tracing is probably means you can fly blind with your system because metrics useful for monitoring individual components in the system. And specifically, they're good for monitoring. Like they're very accurate because they're compressible and aggregatable very easily. So you could have very precise numbers and alerts on top of what happened with the system. But if you then want to actually understand what's not working, how to troubleshoot a particular issue, then metrics are not a great tool at that point. Logs are helpful, but logs at scale become very expensive. And so tracing not only is less expensive than logging because it samples intelligently what the request is going through, but it also gives you a complete view of the system rather than one single node. So you get a macro view of the whole transaction, how it touches 50 different services. And at the same time, you can drill down into individual one and still see a lot of rich details about what that transaction was doing in that service. So it's a micro view, which is actually ironically very similar to login, but login can't get you that if you don't do the context propagation correctly.
One of my favorite blog posts from a few years back, Martin Fowler wrote a blog post where he talked about this idea that you must be this tall to be able to develop microservices. As you mentioned before with tracing, you're flying blind if you don't have a tracing tool at scale with microservices. Is tracing now required? If you're running microservices, must you have tracing? Must you be this tall now?
I think, again, it goes to the question of scale of the complexity, right? If you have microservices, but you have 5 of them, you potentially can get away without tracing. right? If you go to 20 or, 3,000 like Uber, then it's probably impossible to do without tracing. You need to get it in. It becomes table stakes at that point.
Absolutely. It makes total sense. I like that answer with complexity being part of the scale. What are some common mistakes you see people make with tracing?
I think tracing is actually a pretty young discipline right now, so not a lot of people are using it still. And so one mistake that people make, not just with tracing, but actually with all the three pillars that you mentioned, is that thinking that by having them in place, you solve your observability problem, right? And if you look at the history of what tracing was originally designed for, a lot of applications had to do with performance optimization. Like, how do you take care of my latency and investigate where the latency is coming, right? And when we deployed the Jaeger at Uber, that was also our initial goal. And we eventually realized that that wasn't a prevalent use case for Uber of using tracing. We eventually moved into the direction of saying, well, we use tracing to actually understand what happens with our requests, to perform outage resolutions, to find where the problem is in this massive architecture of interconnected components, rather than just saying, okay, I'm going to look at one single trace and see which span is the longest, and that's my latency source, right? So again, just having traces in place doesn't really solve your observability problems. You need to know what kind of issues you are trying to solve with them. And then on top of that, you may need to do something special with the traces that may not necessarily even be available out of the box somewhere. For example, at Uber, we have an aggregation system which is not open source, which is pretty tied to how certain pieces at Uber operate. And it continuously aggregates traces and helps us tremendously with the root cause analysis, or not root cause analysis, but like outage resolutions and mitigation.
What types of questions should you be asking when you're developing an open tracing solution?
With OpenTracing, there is pretty standard way of instrumenting your code. So hopefully you don't need to answer a lot of questions, I think, with deciding how to get about it. Once you have an instrumentation, then you can start answering a bunch of questions. Like I've heard, we've done a bunch of case studies with users of Jaeger in open source. We've published a couple of them, like from Ticketmaster, one more coming up soon. And so people are using traces surprisingly for very different things, right? One of the examples is saying, well, when you onboard a new engineer, you can use tracing as a documentation tool, which describes you up-to-date architecture of your system, because it always watches what the system is doing rather than going by some document which is stale after, right? So whereas another team said, we used to log a lot, and then we stopped logging completely and only started writing logs into the traces, because tracing system allows you to look at the logs of a single request rather than a bunch of like tons of logs from a single process where all the requests mixed up, right? So it's very different by like what the needs of the organizations are, and you can use tracing for various purposes.
So, talking about like system level events, are certain things that you should use logs for, you should use metrics for, and you should use traces for? And what are those things?
So I think metrics, as I mentioned, are very useful for getting very accurate numbers about what your throughput is, how many requests you're processing, like errors, etc. And so if you want to build alerts, you probably don't want to rely on heavily sampled data such as tracing, because you're always going to get approximation only, and they're going to be averaged. You're going to lose anomalies and things like that. Whereas metrics are very precise for that, and they're cheap because they're heavily like aggregatable. They're just numbers at the end. And so I definitely recommend people use metrics for that, even though there are some vendors today who offer similar functionality purely based on tracing. At Uber, we have a completely independent metrics backend, which is highly scalable to like billions of time series per second or something.
M3, right?
M3, yeah, M3DB. And so I think that's perfectly valid use case, and traces are not necessarily need to solve that space. But that's just monitoring. So as soon as you fire an alert and you know something is wrong, then you want to find out what's wrong and where. And at that point, metrics don't really help that much unless you start putting tons of dimensionality into them, which becomes very costly at that point. And so you turn to logs or traces. And as I mentioned, logs are very expensive. There's a conference talk showing like a multiplication factor with logs, like every microservice you multiply by the number of services, et cetera, et cetera. So logs with microservices especially become even more expensive than in monolith. So you can't log everything. So if you want to troubleshoot certain things, you need to focus into like sample data, and that's traces usually give you a much better view of the sample data because their request scope. So you would look for those. But yeah, ultimately, I see that those three are still useful. It just depends on you use different things in different situations. And plus, logging can be very useful for things like troubleshooting the startup process of an application, right? There's no request at this point. There's no context. There's no trace. You're just starting an application. There's certain activity which happens only once. Something breaks. You want to get that logged and get to that if you want to troubleshoot. Because like tracing is completely not for that use case.
So I want to ask about some common stumbling points with people implementing tracing. So I want to start with like day one. What are some common things that people stumble on when first deploying a tracing solution? And then day two, after you've operated it for a little bit, what are some things that might catch some people unaware? So start from the beginning. Like you have logs and metrics and you want to move to a tracing solution. What are some things to think about? What are some common gotchas and what should I be considering?
I think the biggest challenge in rolling out tracing is getting instrumentation into the correct places in your application. With metrics, it's interesting because I always say that it's a conflict of interest in terms of who benefits from rolling out traces. If you are owner of a service, a specific service, you are highly incentivized to instrument your code to emit metrics and to emit logs because ultimately you are the one who's going to be looking at it and you understand what your metrics mean. If you are talking about benefits of tracing, the benefits are more at the organizational level, not an individual service.
The aggregation.
Exactly. The whole path needs to be traced properly to get the best. Like the more you instrument, the better value you get. And then an individual service doesn't get directly that much value. So if you are an owner of a service and management says, you have to do tracing, you say, well, why? Like, I don't get any benefits from it. It's only like SREs who sit and look at 50 services that get benefits. And so that's a big challenge, I think. I don't know how to solve it. There's like various incentivizations paths probably, but it's a hard problem to solve organizationally. And so that's the biggest challenge of rolling out traces, to get instrumentation in all the right places. And there are various techniques to do that. Like I mentioned it in my book, that one of the approaches we took at Uber is that rather than having Uber services depend on open source Jaeger, we built internal wrappers for Jaeger client, and we make them depend on those. Because those wrappers allow us to provide a certain customizations which are specific and relevant to Uber. And plus, we're able to upgrade people faster. Like we are migrating to monorepos all of the services, so that again, it gives us a central point of control for my team, for the tracing team, of control of like what people are using, doing the tracing. So those are very important things that you want to standardize your organization on these software development practices, rather than having everyone just grab something from the internet.
So the first challenge is organizational, not really technical. Interesting.
Mm-hmm.
What about after you've been operating microservices for a little bit? So day two problems. What are some things that might catch some people unaware?
So day two is, again, instrumentation challenge. I think you are never done unless you have, I don't know, your whole code base is written in one language using a single framework, which is never the case with microservices. They intentionally polyglot in different languages, frameworks to give freedom and velocity to engineering teams. And that creates like an extra dimensions for tracing. You have to like instrument all of those things in order to continue getting the picture. And so we've been doing tracing for 4 years now at Uber, and we're still nowhere near 100% coverage for all the services, right? So that's going to be a continuous challenge, I think, for all organizations. So especially for large ones.
So I'm curious about your thoughts with service mesh. So one of the misconceptions, call it what you like, is that if I put a service mesh in there, I can plug in a tracing framework and I can very easily get tracing without having to dive into each individual one of my polyglot microservices. Is that true? What's the reality of that?
Unfortunately, it's not true. Tracing does not work with the black box approach to that application. A very simple example. If I have 10 requests coming into service concurrently, and each of those requests execute 5 downstream calls. So I have 50 outgoing requests. How do you correlate what 10 inbound and 50 outbound have to do with each other, right? So for tracing, you need to be able to correlate it. That's the power of tracing. And so if you treat your application as a black box, there's no way you can do that correlation, especially in real time. And so the way service meshes, when they say they can do tracing, they rely still on application doing some minimal amount of work to propagate the context. And ironically, if you try to instrument any application, the propagation of the context is actually the hardest part of implementation. Because to make sure that your request contains a tracing context, that's actually very simple. You just wrap your client or your endpoint in a certain middleware, and boom, you got the wire format represented correctly. But if you have multiple threads going on in application, some asynchronous processing, in order to pass the context from ingress to egress. That's the challenge. And that's what OpenTracing instrumentation and OpenTelemetry, they really provide a mechanism and framework for that. But without that, service meshes just don't provide any tracing, right? And so like a famous example at Lyft, where Envoy is like one of the famous service meshes tools, they had like almost universal tracing thanks to Envoy, they say. But in practice, it's because they had context propagation built into the application, at least in some form of headers passing through like inbound to outbound. And that's the critical bit.
So talk more about context propagation. What do you need to do to really understand internal for context propagation?
So context propagation means that we need to carry some correlation ID with that request all the way through all the microservices that the request travels through, right? And the way to implement it is heavily dependent on the specific programming language that you're using. For example, in Go, standard library provides a standard object called context, and all the applications are incentivized to write them like functions in a way where they pass context explicitly through all the call graph inside the process, right? So context propagation is almost taken care of by the application due to other reasons rather than tracing. But the same thing doesn't work, for example, in Node.js applications where there's no standard framework for context propagation. The thread locals don't work that great, especially in the early versions. I think in the newer version, they started building something into the runtime where it can automatically keep the context as requests like get put onto the event loop and taken back again. So you can do that obviously with a framework, but unless in the past versions it wasn't there, and instrumenting node services was a pretty challenging thing. You actually had to go and change a lot of functions to pass something through the call path, right? In Java or similar languages where you have thread locals support, things are a bit easier, especially in the old style applications where you had a single thread handling a single request. That was very simple. You just stick your context in the thread local. It's available everywhere where the request goes. But modern frameworks, even in Java, they use futures, they use multiple thread pools. So again, thread locals don't work out of the box. You need some special instrumentation of the concurrency primitive so that the context properly transfers to the code.
All right, I want to change gears just a bit and talk a bit about aggregations and how you actually kind of use these traces. So a lot of times I hear people talking about specific traces and tracing individual requests, but that's not really the power. A lot of it's embedded into specific tools, at least I've only seen it in specific tools, where you can do things like aggregate with like P99s. Can you talk a bit about that?
Sort of percentiles is one type of aggregation which you can definitely do with traces. Or more specifically, you can do that with metrics, but then you can investigate that with traces, right? Once you see the specific P99 going wrong, you can try to drill down with traces. But I think the real question about aggregation of traces is that when you look at one single trace, just from pure like arithmetics, Jaeger generates probably several billion traces a day. How many engineers can you have looking at each of the trace, right? So, by the way, we sample very heavily. Our sampling rates are between 1 in 1,000 to 1 in a million, depending on the group, right? And so, even at that sampling rates, we still generate billions of traces a day. And so, the question is, how many traces people can actually look at during the day? And so, obviously, a tiny fraction. And so, why we're collecting all this data is like if you're not doing any aggregations and data mining on top of that data, you're just wasting your resources. And so we started doing aggregations last year. I mean, there are certain simple aggregations like the dependency graphs. Those are a very high level thing. But specifically, in order to investigate problems, if you're looking at one single trace and you're saying, well, this latency doesn't look right, or maybe there's an error here, should I investigate that error? To answer that question is actually very hard because, well, one trace doesn't give you any context into the normal behavior of the system. And that's where the aggregation power comes in. It says, okay, well, why I can compare that with what the normal behavior looks like. And maybe that's normal latency. That's always like the case, right? Or maybe this is one single trace, it's a complete outlier. You shouldn't even bother investigating that latency because that almost never happens anyway, right? And so that's, I think, where the future of all the tracing is. And I agree with you, not a lot of tools do that today. I think it's a fairly new area. The tool that we build internally helps us to isolate problems in the architecture when we have an outage. And the challenge with the outage is that you typically declare an outage when some of your business metrics is showing some problem, right? So let's say riders in New York cannot take a trip, or we see a dip in that rate of trips, right? So that's a very high level business metrics. how do you go from that to any sort of architectural placement anywhere where you try to identify the problem, right? And so what we've built is a tool which says, okay, well, let me look at those traces where I know that error has happened, and then compare those traces with the normal behavior of the system, which is aggregated from many successful traces. And I presented this at the QCon New York in June, the visualization tool that we built specifically for that, which visually shows you how a particular trace is different, either structurally or in terms of latencies, from that aggregated model of successful behavior. And that allows you to very quickly zero in onto the specific spot in the architecture where the problem originates. And so tracing may not actually solve the problem. You may still have to go and investigate it with whatever other tools. But without that first step, it's going to take you 30 minutes even to find where the issue is.
Where to start.
Yeah, where to start. Because you're looking at, okay, I'm very high level business metrics is wrong, but how to get to that? So I've heard Charity Major tweeted once is that the hardest problem is like finding where it's broken, not why it's broken.
So the tool you just talked about was specific to Uber. It's closed source at Uber, right?
Visualization of it is open source. It's in Jaeger. The actual aggregation part is currently closed source. We probably open source it. I don't have concrete plans yet, though.
Are there tools that you know of that will do different aggregation that people could look at?
Well, I know that Haystack by Expedia and Apache Skywalking, those are more of a APM products rather than pure tracing solutions. So they provide certain types of aggregations. Haystack even has ability to watch trends and then do alerting on top of trends. But I think those are mostly on the time series data rather than tracing data, right? So I have not seen any tool which says, oh, your shape of the call graph is looking differently than yesterday. Let's alert that. That's, I think, is an interesting new direction that will appear in the future. We plan to do that, but not immediately.
What about things like serverless? What is the state of like tracing when it comes to serverless applications? And I'm specifically talking about like insight into like warm up times and things like that. Do you have visibility into that with serverless? Or are there any challenges around serverless with tracing?
So I myself don't have a lot of experience with serverless. I have some users in open source, users of Jaeger who are asking for serverless. And fundamentally, serverless are very similar to microservices. They just like more granular. And so you can trace microservices, you can trace serverless just the same way, right? There's no conceptual difference there. There are some practical implementation details in terms of, like you said, like warm-up time, what is the identity of the service? Because in the microservices, we typically, when we look at the trace, we say, oh, this service emitted this span, did this operation. With the serverless, you want to be careful about what you name those things because you don't want to have a UUID somewhere and say, this represents my whatever, right? There's no semantic meaning in that. Another technical detail might be is that our typical recommendation for Jaeger is that you run a Jaeger agent on the host, either as a sidecar within your pod or as a host agent, so that your client library can talk to that agent directly over UDP very cheap. In serverless, that's simply not possible. You can't deploy a sidecar. So you need to do something else. Typically, you just report spans over some persistent connection. So those are more of a technical differences between microservices and serverless. And yeah, warm-up time, that's, I think, is something that goes back to my point about why logs are useful for startup time, because warm-up time of a serverless is like a one-time only thing, right? Once it's running, then you have requests, you have context specific to the request, you can do tracing. But until you get to that point, the tracing doesn't help you. You probably want to look at the logs, at the metrics for those.
So what's next for Jaeger? What's on the roadmap?
We just almost finished developing of a new visualization tool, which we call deep dependency graphs or transitive dependency graphs. So historically, Jaeger had this topology graph of your architecture, which was constructed from traces, but based on peer-to-peer connection between services. So when you look at that graph and you see service A call B, B call C, you don't really know whether A directly reached to C at any point, right? It just, information is only one hop away. And so transitive dependency graphs, they look at the whole path of the request. And that allows a much more thorough investigation of architecture and of the problems and dependencies between the services. So you can look at what operations specifically happen for a top-level endpoint. You can see how it goes through the microservices. So I have not seen any tracing system have that kind of feature. We had a prototype at Uber internally. It was very popular with users because it again, reveals much richer information than just a single hop service graphs, which, by the way, you can get with service mesh, the one hop versions. Another thing that I'm trying to put it to open source, we've been running with it in production for a while already at Uber, is the adaptive sampling feature, where our backend constantly monitors how much traces each service and each operation within the service generates, and then adjusts sampling rates or sampling policy more specifically to sort of control that better. For example, one challenge we had is that when you have an API gateway, you may have one point which is called once a minute and another point which calls like a million times a second. If you assign a single sampling rate, which is what most tracing libraries do today, like if you pick any Zipkin library, they usually have a sampler, a probabilistic sampler, which is only one per application, right? So you can't have both of those two endpoints basically producing a reasonable amount of data with a single probabilistic rate, right? And so what we've implemented is more sensitive ways of doing. Like you can sample 100% of that low QPS endpoint and only 1 in 1,000 of high QPS. So that's probably the biggest thing that we'll try to finish by next KubeCon, hopefully.
So you wrote a book called Mastering Distributed Tracing. If people want to know more, they check it out. Give us the 2-minute pitch on the book.
So the pitch is, when I started doing tracing in 2015, there was not a lot of information actually anywhere. So there's some random blog posts, the Dapper paper, obviously. So you can get a basic idea, but there is no practical guide of how do you go about it in a large organization. What is the order? Why are you doing things? What specifically aggregations, machine learning tools you want to build on top of that, and how to use that, how to incentivize people to instrumentation. And so after 3 years of doing that, I realized that I actually have a lot to say on the topic, and that's the topic of the book, basically. It teaches you from very basic how you set up tracing of a small application, and then talks all the way through to how you extract data, what you do with the data, what organizational challenges you need to solve, what deployment issues specifically with the tracing infrastructure you need to deal with. So it's kind of all very broad coverage of the tracing area.
Very nice. Well, you just increased my reading list. Thanks. Yuri, thanks for joining us on the podcast.
Thank you for having me.